Okay, after you check over this homework, we are going to move into our next section, which is square roots. So we're going to simplify, add, subtract, multiply, and divide some square roots. This should be familiar to you, it should be, a review, but we're going to definitely take it and as if we're learning it again. Most of us in the room probably feel pretty comfortable about the square root of 4. We all in the room would probably say, oh yeah, Mr. Drug, that's 2. Well, what we are doing is breaking that down to 2 times 2, right? And what do we know? We need sets of 2. So here's a set of 2. The index here is 2. So then that's how we end up with just 2 as the square root of 4. Now, versus what we'll be doing a little bit more would be something like the square root of 8. Takes a little bit more effort with us. There's 2 ways to go about it. We can look for perfect squares, or we can do the factoring. Let's do the factoring method. 8 would be 2 times 2 times 2. Now, our index here is not there. It's always understood to be 2 if there's nothing. It can be a cube root also, but this is all squares. We need a set of how many there are. Well, how many of them are there? Well, there's exactly 3 of them. So we're going to take 2 of them out. So they come out from underneath. There's 1 left over, so it stays. And that would be 2 square roots of 2 will be simplifying the square root of 8. Bring back some memories for you. So the factoring is one thing. You can look for perfect squares also. So we might want to jot down a couple of perfect squares, of course, if you remember. 2 squared is 4, so there's a perfect square. Of course, 3 squared is 9. 4 squared is 16. 5 squared, 25, and you can keep going there. The next one, of course, would be 36. Then 7 times 7, 49. 8 times 8, 64. So you can look for these perfect squares underneath your radical, and that can help you also. So for example, on this square root of 8, a second method, okay, so this could be one way to do it. A second way would be, okay, I have the square root of 8, which is really the square root of 4 times the square root of 2, is it not? 4 times 2 is 8. So now I know, oh, well, the square root of 4 is 2, and I can simplify it that way. I don't care which method you use. If you want to look for some perfect squares, that's fine. Or you just want to factor all the way down and look for pairs or sets, 2 sets of 2. Let's try a couple. That's everything we just talked about. I think we're okay. Square root of 32. Square root of 32. Now the thing about this, I'm going to decimals to be counted wrong. Okay, so we're not looking for a calculator and putting square root of 32. We're looking for simplifying this guy down. There is a perfect square in this one. There's also a whole bunch of 2's. See what you can do. Give you about 30 seconds. So if you're doing the factoring method, which sometimes people do, you could say 16 times 2, 2 times 8 times 2, and then you're going to end up with 2 times 2 times 4, which would be a couple more 2's, times 2. You get a lot of 2's there. So underneath there we have 5. Well, we need sets of 2. How many of those are there? 1, 2. So in fact, this is gonna be 4 square roots of 2. So this is all under the square root, taking those out, oops. Taking that set out and that set out. There's still one guy left at home that doesn't have a prom date. Also, the perfect square option is in play here. This could be the square root of 16 times the square root of 2. So hopefully you see why 16 times 2 is 32. That's looking for perfect squares. Again, either method works, okay? So this is gonna end up being square root of 16 is 4, and that comes along for the ride. And you can simplify that way also. So everybody feeling okay about this? There's no decimals, all right? Stay off the
Your attention,
decimals.
please. We are looking for freshmen with last names beginning with I through T as in Paul. Please go to the Performing Arts Hall now to have your picture taken. Thank you. That's freshman I through T. Thank you.
Now, we can rewrite this one as the square root of 25 over the square root of 36. Now, why do we like 25 and 36? Because they are what? Perfect squares. Square root of 25 is 5 times 5, so it ends up just being 5 here. And of course, the square root of 36 is 6 times 6, which is 6. And I have my match. I have my guy there. So if they're written as a fraction, we can split them and move forward there. Let's keep going, just trying to put a couple in play and just work on practicing today. Now, when we have 2 of them listed and we're going to multiply them, we can do that first or we don't have to. In this case, it might help us. What is 3 times 12? 36. Much easier. Square root of 36, of course, is 6, so we can roll. Now, do you have to do it that way? Not necessarily. You could put all this underneath the factoring. It'd be 3 under there. 12 would be 3 times 4, or 4 is 2. So you could do that. To me, that's a lot of extra work, isn't it? Okay? Now, a set of 3's come out, so now I'm outside with wonderful 3 times 2, and we end up with 6 anyways. I'm trying to give you a couple different ways. Don't get locked into one particular way. Look for those perfect squares because they are a little quicker, and you can get to the solution a little quicker. How are we feeling about that one? Everybody okay? I'm not going too fast here, am I? See a lot of people jotting stuff down. Is everybody okay? Fantastic. Now this guy here, it helped us to multiply first. Sometimes it might help us to divide first. So we can rewrite this with a 500 over 5. Now, I'll do a little easy math there. 500 divided by 5, of course, is 100. So we really end up with the square root of 100. And we know that that is also a perfect square, 10 times 10. So we're quite simply down to 10. Woo! How we doing there, friends? Everybody okay? For you from Algebra 1, you already did a little bit of this in geometry at the end when you were rationalizing. You did the 30, 60, 90s, and you did the 45s. Remember doing those at the end of geometry? Those special right triangles where they have the ratios. You probably were simplifying some of those radicals not that long ago. All right. See if you can do these. I'm going to give you about 42 seconds. Do I do a little self-evaluation here? See what you can do. I call this guided practice. I'm going to ask you to do it, then I'm going to do it, and then you can say, yeah, I know what I'm doing. Or you say, ooh, I don't know what I'm doing. 48. I see a perfect square in there. I see a perfect square of 16. If you don't, that's okay. You can factor tree it. So I do see a perfect square of 16. So I'm gonna write square root of 16 times the square root of 3. 16 times 3. Again, if you don't see that, you might, what might come to your mind would be 12 times 4. Some of you might go with 6 times 8 because that's pretty popular because that's factors we learned back in 5th grade. So if you do that, that's fine. You just break it down. I'll do 6 times 8 in a second. So I know that's going to be 4 square roots of 3. Not a very good 4 there. So some of you saw 8 and times 6, okay? That 8 would break down to 3 2s. That 6 would break down to all those 2s. And now we're looking for sets. So do we have some sets here? We certainly do. We have those coming out. So we end up with 2 times 2 times square root of 3. And you can see where we get our 4 square roots of 3 there also. I don't want to confuse you by doing both ways, but I want you to have the option so you don't see the perfect squares. Letter B down there, piece of cake. What's that end up being? Square root of 36 over the square root of 16. We are 6 over bad golf shot 4, which I hope we don't hit too many of those today. And we'll simplify that down to 3/2. How are we rolling? Everybody good? All right, let's keep rolling. Simplifying radicals. Again, sometimes it might help to multiply first. You might think, oh, what's 5 times 20? Is that an easy one? It might be. You might look at 147 divided by 3, see if that's an easy one. It might be. If not, we'll have to do something different. You have to rationalize, which we're going to get to here in a second. Okay, 5 times 20, of course, is 100. So we're down to the square root of 100 here, which is awesome. We know it means 10, don't we? We could rewrite this guy as 147 over 3. If we do that math underneath there, we're going to end up with the square root of 49, which is pretty cool also. 7. How are we feeling? Okay? Questions or concerns about simplifying some radicals? I have a couple practice for you, problems for you a little later. Is everybody okay? Let's keep moving then. All right, rationalizing the denominator. One of the more trickier things here. When we have a radical in the denominator, we will need to rationalize it. So that can be sometimes a little time consuming, but as you'll see, I think you'll remember. So there's what we're talking about, a situation where a radical is in the denominator. Walk you through this one. Some of them can be a little harder than others. So really, as we did the previous problems, there's nothing we can do with the square roots here. It's just kind of down there, so we're gonna have to do something with it. Okay? So, if I have a radical denominator, about 90% of the time, we're just gonna multiply both top and bottom by that, so. Square root of 2. Square root of 2. I am multiplying here. Now, it's been a while since you might have multiplied radicals, but we just multiply the numbers. 2 times 2, of course, would be what? Square root of 4. We'll come back to that in a second, okay? That's what we're trying to do. We're trying to get rid of that radical. So let's just go ahead and take care of that right now. What is the square root of 4? Of course, it is 2. So there's our goal. Just have to take care of the top. The goal in rationalizing is to get rid of the radical in the denominator, which we just did by multiplying by the same thing. Now, what's going on up top? We're going to multiply what's under the radicals first. So we're going to end up with 3 square roots of 10. Now I want to take a look at the square root of 10. What is the square root of 10? It's just 2 times 5, isn't it? Is there any pairs or sets of things that come out of there? No. Can I simplify square root of 10 at all? No, it's done. So this answer ends up being 3 square roots of 10 over 2. Now, here's the part that, the last thing. This, 3 square roots of 5 over the square root of 2, and this are equivalent. They are the same. They just changed the form. We just got rid of the radical. They are exactly the same decimal if we're putting decimal in, okay? So we haven't changed the answer. We just gave it a little facelift and a little haircut. And it looks a little different, but it is the same. And that's called rationalizing. So anytime we have a radical down here, we're gonna multiply both top and bottom by that. Let's try another one. See what you can do there. I'll give you a second. What are we gonna multiply both top and bottom by? Square root of, you could. Square root of 8 is just as easy also. You can just simplify it in. I'm gonna just do the square root of 8 because I think it's easier for most of us, but the square root of 2 would work. We wanna multiply by what's in the denominator. It is a unique situation that the square root of 2 would work here, but most of the time, we're gonna multiply by whatever's in that denominator. So in that case, this would be square root of 8, square root of 8. I ate way too much food the last 2 days. Saturday, I went to all you can eat Tim's Tavern Fish, and I ate like 8 pieces and stuffed myself silly. Yesterday, we had my aunt and my cousin over, and we grilled out, and they brought some really good food. Peach cobbler and ice cream. I was miserable. You never eat food, sometimes when you eat, you just lay there and you're like, what did I just do that for? And that's what I did yesterday. I did it 2 days in a row, so thank you. All right, 8 times 8, of course, square root of 64. What are we getting up top? We're getting square root of 16. Oh, wow, we got perfect squares, don't we? So square root of 16, of course, got gouge out 4. Square root of 64 is, of course, 8 too much. We'll simplify down that. 2.5. Woohoo! Dinner done, is everybody okay? For Monday morning, hanging in there, you guys are awesome, thank you. Let's move on. I think we're okay rationalizing the denominator, but let's try, this will be our last one to rationalize. What are we gonna multiply both top and bottom by? Square root of 7. Square root of 7.
And freshmen, we are now ready for those students with last names beginning with Q through C. Please go to the Performing Arts Hall to have your picture taken. Thank you.
Now, if you get a little better, I'm just gonna skip this step on the bottom. Because I know the square root of 7 times square root of 7 is the square root of 49, right? So I don't need to write that out anymore. Does everybody understand what I'm saying? I just know it's gonna be what down here? 7. Because I've accomplished my goal, I wanna get rid of the radical. That's what rationalizing is. Everybody good? Okay? Now what's gonna happen on top is I end up with 3 square roots of 5 and 7. Is there anything else I can do with 5 and 7? Is there a pair of anything? There isn't, is there? So it's just 35. So sometimes I might be able to simplify that. In this case, I wasn't. Other times I might be able to do something with 3 and 7. What if this came out as 2 square roots of 35? This is just, I'm making this problem up, over 4. Then we would simplify this, 2 and 4, down to the square root of 35 over 2. So we would just simplify that to 1/2, 2 over 4. Does that make sense to you? If the numbers out front can be simplified, we will. If inside the radical we can simplify, we do. I thought I said last one. Did I say last one? Can you got one in you? We'll make this one last one. And we'll do a little add and subtract and we'll call it a day here shortly. You guys are great this morning on a Monday. You're very engaged. I appreciate it. Thank you. What are we gonna multiply both top and bottom by? Square root of 10. Remember, I can kind of skip that step. This is square root of 100 would be, right? So, heck, I know it's gonna be 10. I wrote it out the first time, but I'm not gonna keep doing that. Here's one where I got some extra thing. Can the square root of 10 up here, can I do anything with this square root of 10? No. But 5 over 10 I can do something with, okay? So this whole kit and caboodle here ends up being what? Square root of 10 over 2. Woo-hoo. All right, simplifying radicals, rationalizing, how we feel? Everybody good? Got a little add and subtracting now. This is pretty easy, adding and subtracting. You can only add and subtract if they are exactly the same. So you can only add and subtract square roots if they are the same. So if they're not the same, we can't make that happen. Huh. Subtract is better. So they just have to be the same, and you'll see as we do a couple of these, this is when we add and subtract. So, are those the same? Are those the same? Yeah, square root of 3. Folks, this is like on Halloween, after your little sisters or brothers go out and get all the candy, they go to bed, you just go and steal the candy from them, right? This is that easy. Make sense? Okay? So we're just adding 9 and 7, and of course we get what? 16 square roots of 3. Woo-hoo. We'll take the whole quiz like that, wouldn't we? Yes, we would. Have to be the same. Now, we can trick you and not make them the same sometimes, but yet be able to do that by simplifying them. So be careful, okay? Because this is one of those. At first glance, I'm thinking, I can't do this one. But I need to think about the square root of 20. Can it be simplified? See if you can do that. To start by simplifying the square root of 20, 4 times 5, 4 is a perfect square, if I'll give you a hint there. Just got the P there, it's gonna be 97, which is 16 square root of 3. Did I go too fast there? Sorry. All right. So this one, similar to the first one, but we got an issue right here, we gotta do something here. And that does simplify. Square root of 20 would be 4 times 5, right? 20 is 4 times 5, which is the square root of 4 and the square root of 5, which ends up being 2 square roots of 5. Now that changes everything. Now we have the same, don't we? So 6, of course, we're right down to first grade math now. 6 minus 2, right? 6 minus 2 is 4. And we end up with 4 square roots of 2. How are we doing there, Sid? Good? I mean, you're staring at your computer pretty strongly there. That tells me you're not doing what I'm doing. Not to call you out too strong there, but. Oh, we're looking at. Yeah, girl.
Should be 4 square root of 5.
That's what I
Oh,
was
duh. Yeah, thank you. Thank you. Hey, everybody, that should be 5. Thank you so much. Of course it should be 5, because we have 5 and 5 here. Monday brain fart, there you have it. Thank you. Let's hope that's the only mistake I make today. I'm sure I'll make another one somewhere along the line. Oh my goodness, how many of these do we want on the quiz?
open.
All of them. Same thing, add them up. What's the answer? There you go. Oh my goodness, what the heck happened there? I think I just did something that I shouldn't have done. Didn't want that tab. Get rid of that. Oh no, that might be really bad news. Stop, ignore. Lost the smart board, didn't we? Try and get it right here, see what happens. Nope, you don't want to recover. No, we don't want to recover. Take the old one. I'm not sure what button I hit there, but it messed up, didn't it? All the writing's gone, we've gone through all that. We were done with that one, that's what we just did, right? Last one. What are we pretty sure square root of 8 is probably gonna end up being? Something radical 5, something radical 5, okay? We're pretty sure that can happen. Something radical 5. Now, 80 is there's a perfect square in there. A perfect square that's in 80 is 16. So that might help you a little bit. In fact, it's 16 times what? 16 times 5. So if that's the case, I know I'm gonna skip a little bit. Okay, it's 16 times 5, so that, my friends, is 4 square roots of 5 minus 5 square roots of 5. So the final answer here is negative square root of 5. It's 1, but we just went right 1. Square root of 80. 16 times 5. Is everybody okay with the square root of 80 and how I got that? I skipped a little bit, I went straight to it. Is that way good? Fantastic. I think we're pretty close. What do I got left? Yeah, we are. Woo. All right. All yours. Affectionately. Just a few odd problems, this is good practice. Go ahead, you know how to go about it now, submit that on Canvas. And we will roll. You bet.